Hello, everyone. Good morning, good evening, good afternoon, from wherever you are tuned into this intriguing and exciting webinar. We call this the Co-Create.ai series presented by Network Science. I am your host for the session. My name is Prashant. I am a deep tech consultant at Network Science. At the onset, let me introduce you what Network Science is all about and why are we even doing this. Network Science is a deep tech innovation company, and we are proud to co-create innovation with some of the big enterprises in the world, such as JP Morgan Chase, Adani, Mahindra's, Schneider Electric, H&M, and the list goes on. We believe in bringing big and fast change and getting things in the first time right. As for today's discussion, the webinar is titled The Digital Twin Advantage, Driving Innovation and Efficiency. We all know how critical technology has become. It's just not, it doesn't stop just affecting the industries, the businesses, but also, if you look around it, our daily lives too. As for today's discussion, we attempt to deep dive into one of such deep technologies by the name digital twin, erstwhile virtual twin. Let me start with a story. It was April of 1970, and there was intense stress into the headquarters of NASA. The scientists and engineers were feeling dreadful about their Apollo 13 program, which was about to fail. At that time, the oxygen engine would blast and cause a lot of damage, which was a danger both to the innovation program of space as well as human hazard that it would cause. Thankfully, the engineers and scientists had designed a simulating environment within the office so that they could redo the programming and think of a better solution on how better they could prevent the problem that was at hand. It was 200,000 miles away from Earth, and the mission was eventually successfully unsuccessful. So we see this was an advent of digital twin back in 1970s, and come 2024, we have innovation changing our daily lives. One such expert joining us today is Mr. Madhavan. We fondly call him PG. He's an industry veteran and has over 4 decades of experience, 2 decades plus in the deep tech domain, especially in the digital twin world. He has been an ad. He has spent a lot of his project work. Some of the remarkable, noticeable work that he has done is with Rockwell Automation, G Aviation, and NEC Corporation. He currently serves as the managing partner at Enterprise Minds. Sir, it's a pleasure to have you and welcome you to this special edition of this webinar. Why don't you introduce yourselves and get started?
The pleasure is mine, Prashant. I think that story that you related is quite interesting. You know, the first digital twin was indeed the NASA from 1970, but it's amazing to think that it is pretty much common occurrence now. We are doing digital twin of all kinds of things. Sometimes we call it, you know, patient or human digital twin, not just of equipment. Now, I had a chance to do this from the very start. I claim, so are you seeing a slide of mine with my face and so on? Good. So at Rockwell Automation in year 2000, I believe that was the first industrial scale large IoT and digital twin deployment. So I had the privilege of building that with the team and deploying it in large paper plants and steel mills and so on. So, so it's at least started in 2000. But remember, at that time, there was no IoT, there was no digital twin. It is just, collecting data. People used to walk around with a handheld, collect vibration, temperature, then come and connect it with a serial port to the PC and put all that data into a spreadsheet. That was the technology there. So when I joined Rockwell, I said, hey, we can, wireless connectivity, internet is starting to really take off. So we were able to monitor a paper plant in China sitting here in the United States. So, it really started from there, and then I stuck to it and jumped like 20 years forward and was working for GE Aviation as a principal data scientist. So jet engines, as they fly, we are continuously collecting a ton of data, and that is uh, some analysis is very necessary because there are a lot of regulations. If some certain sensors fail, you cannot take off, and so on. So some really heavy uh, algorithmic work was required to get to that one. The third interesting thing piece here is while we've been working on ML, AI, I won't use AI so much because this work and digital twin especially is really machine learning. So machine learning gives you some, and it is mostly based on probability or statistics. But at NEC, I learned that there is something beyond that called causality, which really takes the game to another level. So what I've been doing is bringing all these things together. That's just rather lengthy introduction to myself. But what that got me here was this. This is a digital twin story. Twin arc is just, you don't have to really pay much attention to it. Think of it as the culmination of evolution of digital twin over the last 10 or 20 years. So when I go to customers, one of them is a major manufacturer in India that you probably know very well. So the head of manufacturing was saying they have deployed one of the top IoT software solutions, collecting tons of data from the manufacturing floor. So he was saying, we have this 1 year long tons of data sitting there, but we don't know what to do with it. So it is like that man sinking their hand over the water line. So that's still the situation because there is what multiple levels, and I'll go into it where you just collect data to get visibility. So this could be for a machinery or for a city or for a human being, and so on. Now, once you get that information, which is just raw data, you have to process it to generate information. And from information, there are higher levels of valuable fractions, if you will, that you need to extract so that it is more and more actionable. By the way, I'm not saying it's a bad situation in IoT. IoT, some would say, per Gartner hype cycle, it's in a trough of disillusionment. It was about 5 years ago. It has gotten better, but still, again, a lot of data, which is fantastic. Without that, nothing higher can be done. So it's wonderful that it has all come together. So finally, my realization and what we have done here and created a end-to-end solution in this twin arc is really built causality into this system. So the arc, twin arc, the name comes from the figure in the bottom right-hand side. So it is an arc of improvement. So for the customer, you go from visibility to robust information to insights. So that is what this a digital twin takes you, that journey. Most of them that's currently available stops at the level of information, stats, digital twin that you can see there. So let me ask Prashant if this is fairly along the lines of what you were thinking in your own knowledge of digital twin and where digital twin is today.
Yeah, I think it's great to sit with someone who has had an experience in academia himself. So I just want to introduce again of you being a leading Ivy College business professor. So of course, it's exceeding the knowledge and exceeding the information and can't wait to discover more from you.
So people ask, what is digital twin good for? It's good for, you can see on the slide, a variety of things, a variety of verticals. Now, this is mostly I'm an engineer and I'm looking at engineered systems, but clearly, I remember when I was in Japan working for NEC, I proposed something called grandma digital twin. So in Japan, it's an aging population, right? The older folks are up in the mountains and the farms. Now all the kids have left and gone to Tokyo. So they're always worried about their grandma. Is she well? So again, an IoT system, some cameras and IoT system that'll count the number of pills she took. All that information comes to the grandkids working in Tokyo so they can see in a proper UI, which is integrated back to the local health delivery and healthcare folks. So, so it could be a grandma's digital twin. So the idea is that anything physical can have a digital twin. Now, you don't want to do it randomly because you want to get value from it. So these verticals are where that has been established. There is tremendous value to be had. Now, what we are trying to do is increasing more revenue. So more value from this. So you would have heard the phrase, data is the new oil, right?
Yes,
Now,
very,
I
very
would
popular.
say that if data is the new oil, digital twin is the oil refinery. In oil refinery, as you go up the fraction distillation column, you get more and more valuable thing. At the bottom, what you get is lubricants and like grease and things like that. In the middle, you get kerosene. At the very top, that's when you get gasoline, petrol. So it is extremely useful. So the levels similarly in a digital twin. So this is our digital twin stack. Anyone could build this stuff. Now, typically, what is available in an IoT, industrial IoT software is the bottom layers. So L1, L2, and L2.5. I've kind of used the IP stack terminology. So that's generally available. Now, lots of people after these are big companies like Cognite and Litmus and others do this very well, and there are some startups. Some of the startups in the IoT ecosystems have been kind of withering away. They're not doing too good at this time. Um, some of the investments have kind of gone aside. That is because they can't take it beyond. Initially, getting the data and visualization is great. Customers love it. Wow, this is great. But then their CFO or CXO will ask, okay, this is wonderful, but what's the value we are getting? How are we generating some top line revenue or margins? How are we improving the top line margins? And there are no answer. What you need is information and understand the interactions and go up to the level of insights. So some of the IoT raw platforms do a portion of L3. That is, they do, this is condition monitoring and predictive maintenance. But we have some extra robustness that we bring to it. So as you go up this stack, I don't want to belabor a lot, but the bottom of the stack is really, it tells you what happened, when it happened. Let's say you think of a bearing in a machine. So when it starts to heat up and it's about to break, either it predicts or detects one of the things happen. So it's essentially what and when. We need to go beyond what and when for digital twin to really impact the top line gross margins. That's my objective is always improve gross margins. How do you do that? And
Yes.
we believe to do that, we need to answer the question why and how. So let's say something failed. You want to know why. Causal analysis. We call it root cause analysis, right? Because then we know we fix the problem, so we don't have to fix it again and again and again. So it's like going beyond just keep giving medicine, but go find out what is a problem and then try to solve it. So, and then how is another very interesting portion that is really, we call it what if analysis. But the idea is to go beyond fixing and knowing the problem. How do we improve it or optimize it? So optimization is a key feature. So simulation and optimization. So based on the causal graph. The key to understanding that is the causal graph. So from the data that comes, which is time series, right? That data that comes, we estimate these are heavily statistically grounded methods, causal graph. And then we do Monte Carlo simulation and optimization on top. And that information is fed back to the plant floor where you can improve a process, make some changes in the asset so that it works longer and better. Prashant, let me pause and see if you want to reflect on this a little bit before I go
Yes.
forward.
Yeah, before I ask my question, I actually have a couple of them. I'll encourage the listeners who have tuned in to also post their questions, which we'll be taking towards the end. And we commit to you that if not covered in this session, we'll definitely writing you back with your answers. So the first question, Prof and Doc, is when we talk about digital twin, to people in general, they only think that a physical asset is being simulated or emulated. So what we definitely miss most of the times in our discussion is the processes and environment that also can be simulated for analysis and monitoring and statistical uh, optimization, etc. But there is also a third layer, which is the communication channels, which also gets optimized or simulated for that reason. So can you throw light into how processes and communication channels, uh, more towards alluding towards the IoT part of digital twin, if you can just make it easy and break it for our listeners, it would be great.
So there are multiple views in it, but we take a very specific view of, uh, we always start a customer engagement by talking about uh, use case that is important to them. Then within that use case, we say, let's identify your biggest pain point because we want to solve. So our line to the customer is, we give you painkillers, not vitamins. We're not about feeling good and stuff. We want to come and solve a specific problem that you have that's keeping you up at night, affecting your manufacturing or something like that. But within that, always start with an asset. So you start with a specific, let's say this is a refinery process, but so there's a turbine, let's say it's an offshore rig, there's turbine. So start with an asset, then start with the other assets on that platform. Then, so aggregation of assets is how we see it as a process. Now, so from individual pieces to collection of pieces to the large. So there is a what shall I say, a hierarchy and a growth path of how you put together whole processes. So that is basically our approach to assets to processes. Now, having said that, processes are significantly more difficult to create a digital twin, right? Because there are multiple pieces available. That is why we don't take that whole, that it's like the old joke, how do you eat an elephant, one bite at a time. So let's bite one asset at a time, not try to eat the whole offshore platform. You'll never get there, right? So that is our typical approach.
Sure. I think one of the use cases that I get to hear a lot, and very few answers to that, is the use cases around the BFSI world of digital twin. If you can give us one very pertinent example, uh, would, would be great.
In which vertical? What was the question?
BFSI, the banking and financial sector.
Yeah, that is one area. So I have a bias, as you can see here, but if you want, I can try to speculate. My bias is, uh, let's see, yeah, my bias is mostly, uh, I call it engineered systems. So it looks like, manufacturing, smart cities, supply chain, predictive maintenance, green buildings, et cetera, et cetera. Now, banking is outside the purview of what I have personal experience, but if I start thinking about it, I would think about something like some aspects of it, maybe not so much the operational aspects, it may be more in terms of how do you link together the ATM system. So you can think of each of an ATM machine as an asset. Now, the whole process, they're all connected together. So again, I'm going
Right.
for the engineering side of the
That's
banking
fine.
problem, not for the other sides. And on pure finance, if you can use this for, loan origination and improving other banking performance, I'm just not the expert in that area to be able to
Sure.
comment. But
I think if
if you have a client, send them to me. We'll figure it out.
sure, that's fine. I was thinking to the extent of some documentation that can be simulated to see how regulations will affect banking in a certain country or region. Could that be a possibility?
Yeah, I mean, it is, but they are now you're going a little bit away from, we started this one from really starting from IoT, and digital twin is seen as a uh, piece on top. And typical IoT also kind of, stayed with industrial IoT. So most of these things are time series data that is coming, sensor data. That's what is processed and then, further improved. Now, if you have very different, say, like even in a IT computer system, there are logs being generated from various places, and you could create a digital twin of an IT system, right? Now, processing these logs, which is discrete text or something, is quite different from processing time series sensor data, right? So that is still in its infancy. There is a large amount of work to be required. And my sense is it is, for another few years or more before you will see some great applications. So in the next now to the next few years, it is the industrial IoT applications that will take off once we can get them out of that data lake drowning stage and have them
Yeah.
have some real insights and useful thing. And that's what I think we are trying to bring. Again, you don't have to think of it as our solution, but these are the features I believe that are required. The statistical analysis and probability of failure, etc. They have to be really robust. So what I'm going to show is I have a demo for all of you, a live
Yes.
demo, so you may enjoy it. That has to be robust, this statistical analysis. Then you always have, remember, IoT case. There is a sensor data from multiple channels. So typically, people just look at one channel at a time and try to extract various pieces of information. But that is really throwing away a ton of information. You have to treat it like a multivariate time series, which is you take them all together. So I say, when you look at one channel at a time, it is like looking at the world through a straw. So you see just a small
Mhm.
piece, then another channel, you see another piece. You don't see them all integrated. So there is, as far as I know, no digital twin that treats the data as a multivariate time series. It's just technically hard, but people who know how to do it, it's not that hard. And then, of course, we do the causal graph and simulation, the optimization. So all of these features, I'm going to demo it in a actual live demo if you would like to see it.
Yeah, we'd love it. Sure, everyone does.
Okay. Yeah, I'll skip the slide. This is just systematic way of going through, and creating, first understanding what the customer does, then how to deploy this thing over a short period of time, 4 months or so. Okay, so the demo I'm going to show is actually a leading manufacturer of kitchen equipment, not home kitchen, but big like McDonald's and Kentucky Fried Chicken and stuff. You would have seen this big fryer, right? That's where they fry French fries, and chicken strips, and so on and so forth. So this company is the established company. So they wanted us to develop a system where you monitor these fryers, so deep fryers, and they have two objectives, of course, manufacturer. They want to reduce maintenance costs, truck rolls, because these McDonald's and stuff is all over United States or all over the world. But let's just take the United States. So you have to reduce truck rolls, so predictive maintenance and proactive maintenance and all that good stuff. But they also want to be more helpful to their customers so that the stickiness improves. So they want to give recommendations to the McDonald's franchisee at that street corner. Say, if you do this, you can save on electricity or on frying costs. There'll be less overcook and undercook, all of that stuff. So they have kind of a double objective. So without going through this in great detail, let me just show you. Are you seeing a map of North America there?
Yes.
Okay, so now it will be a little dislocation. I have to go to this a live demo, so I have to go to this other screen and change. I have to stop sharing and then start sharing the other screen. I believe it is, which is the screen? I think this is the screen. Okay. Are you seeing a screen now, which
Yes.
North
It
America?
shows it shows the
Okay.
map of America with numbering. Yeah.
And you see a hand going around? Okay,
Yes,
because
sir.
I'm going to actively click and do that. So we're not showing all their fryers. They have tens of thousands of fryers. So there's a few. I'm from Washington, D.C., well, not D.C., Washington, Seattle. So let's go to Washington. Hey, there is Lakewood. Actually, I live, where am I? I live right around here. I don't know whether you can see, but it's close to where I live. By the way, here is Redmond. This is where Microsoft is, just for interest sake. Okay, so this is one of the fryers they have at. I'm not sure which. Uh, whether it's McDonald's, you can select by customer and all of that stuff. But in this demo, let us just do it. So this is the whoops. This is the uh, there are various ways digital twin, when you think of a digital twin, many times you think of a dashboard, right? You just have
Right.
whole summary. And we do have, you saw all those fryers. I mean, they are not always going to look at one at a time. So on top of this, there is a larger dashboard which just shows how many fryers are on at this time, blah, 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 whatever, that stuff. But this is one layer below, and I'm a big fan of digital twin being displayed in this fashion. So it becomes much more real and close to the people who are working on this thing. So let me, so what it shows is this is what a deep fryer would look like. And what is shown under here is this is in real time, the cook temperature with overcooked, undercooked. The green is good, blue is undercooked. Then over the day, you can actually run this and show over time. So normally, if the French fry was cooked properly, it is this. But there's a lot of undercook, overcook, and undercook, which usually is not good, wasted, or a customer complaint. So this guy said, okay, in this particular Lakewood, this is happening. Let's compare the same fryer in another location. And then they see something like this. In one location, a lot of over fry, under fry. But in this other place, much less. So now, because the manufacturer of this fryer has this upper level information, one of this could have been McDonald's, the other could be another McDonald's or another competitor, Burger King or something. So they cannot find this information. Only the equipment manufacturer can. So he or she would inform them saying, "Hey, look, same fryer in another the same. You're getting we are seeing much fewer overcook, undercook. Perhaps
Yes.
what you should do is retrain your staff, right? You have to wait for the temperature when you go from French fries to chicken or back. You have to wait for the temp. Each one has a different cook temperature. You have to wait. Then maybe this person is not waiting, so that's why you're getting a lot of these things. So it could be an operational this thing, or a manufacturer thinks, oh, some temperature sensor or something in our equipment has a problem. Let's send a person to kind of look this over. So lots of nice information is available from this. So each customer, depending on the use case, will have some special they want to do. And of course, this is not useful for a compressor or an engine or something, right? This is very much about the fryer. So now when I click to expand, what you're actually seeing is now more detail. This is actually we sense the temperature. This is the oil level, the oil flow. This is the current or the electricity draw. So this is just as time goes on. This is not real time. We are running it fast, right? This is the just a simple condition monitoring. Something crosses threshold and suddenly it goes green, red, yellow, etc. So when you click on it, you get more information. So this is where our stats engine, and so not just that it is warning or fine or there's a problem. We go to this stage where we say, hey, what is the probability of failure? So it looks like it's something low, 0.28 or something. But probability, when you just do the so-called point estimation, is very weak. This is a lesson I learned way back in 2000, 2002. So what we do is we do multiple machine learning methods and combine them in a what is called a meta learner to create robust results. So when you look at the robust results, you can see much more reliable information. So in this case, it kind of, coincided. The SATS engine showed at 0.2, this is 0.3, so that's okay. There are some instances here where you'll see that when you do that, there's big difference between robust and stuff. So that is one thing. Now, the stuff that you won't see in any digital twin is this next one. This is called the causal graph. So what this is showing here is this is the current measurement point, this is the temperature point, this is the oil level, and this is the oil flow. So what it is showing is these things are related. There are no digital twin displays or methods that shows not just the points of interest, but how they are interrelated. So this is and just not correlation. You remember the old song, correlation is not causation. This is causation. This is
Yes.
saying this temperature is causing this kind of current draw is causing this kind of temperature rise, and they are back and forth related, multiple relations. So this is estimated. We just didn't stick it in there from tons of data or from these four measurement points. We estimated this and we came up with it. So now you can do fun things like, let us say, so I can run simulations to see, electricity in certain states in the United States is very expensive, like in California or something. So I would say, let us see what should be the configuration so that it'll have 10% less current consumption. So over the year, this is working, like 20 hours a day, or some of them 24 hours a day. You're saving a lot of electricity. It's one of the largest things. So of course, remember everything is connected to everything. So if you just change one link, it is not going to solve your problem. There are multiple things to be changed. So that's why we run this Monte Carlo simulation, and they'll come and say, this is the optimum thing. So in this case, I've done that, and it'll take usually time to do it. So I'm going to change this to say 0.8. And this is because I've done this and I know what that is. So that link changed from dotted, which is negative, to this positive thing. So then if I run this simulation, what you're seeing is the reason why it's flashing is, these are all interconnected. So if you change one, it'll change this, then it'll change that, then it'll go back and change this. So there's a whole interconnection. You can't just calculate once, you got to run it. So now let us see it's finished. Oh, look, if you make this change, the current is almost 10% down, not quite, right? Close to 10%.
Yeah.
But the temperature is just fine. The chicken cook temperature is supposed to be optimal 220, yeah, a little bit higher, so great. But see how it was achieved. Oil level initially was 6 inches, now it is 3 inches, right? So this is called shallow frying. So this is without knowing all of these things of how to do it, by doing this analysis, and because we had the causal graph, we were able to come to this conclusion and be able to do that stuff. So this is really very exciting to us and very exciting to our customer, as you can imagine. So let me bring this back to our slide and
Yes.
stop and see if there is anything that anyone wants to comment on.
Yep. So PG will be taking the questions separately towards the end. But
Okay.
I definitely felt that the demo was quite intriguing, especially if you're a mathematics fan. So this will excite you even more.
Very exciting.
Yes.
So I'm pretty much done from my side. How are we doing for time? We are on time?
Yeah, I think we have 10 minutes to go. Now 9.
Okay.
Yeah.
Perfect timing. Are you seeing a slide which says, what is the takeaway from all of these things? What can digital twin do for you today? Are you
Not
seeing
not
that slide?
quite. Not
Huh?
quite. We are still in that frying pan machine.
Okay, let me. All right. I believe this will cure that.
Yes. Now we can see.
Okay. So what I want to leave you with is the following. All the participants, thank you for joining. There is, as we said, there is just visualizing data useful. Getting information from it, processing, that's great. But knowing how the various things are interconnected within an asset. Now, of course, you can see how we can do this for collection of assets. Each will be one of those nodes in the graph that you saw that are interconnected. And then ultimately insights. So we generated insights for the customer, customer retrain the cook or, change some configuration so you can save money. All those are wonderful insights that you can bring to this thing. So it is all because of this causal inference. Now, causality and causal machine learning is becoming forefront in the machine learning stage. Now, before ChatGPT arrived, causal ML was such a big deal. And now suddenly it has disappeared because Gen AI has like sucked all the oxygen out of news and funding and work. So, but a few of us are still plugging away because we realize how important bringing a causal digital twin to this is. So what that
Yeah.
does is, predictive, which is the statistical methods that is prevalent now, is very useful. But as you know, correlation is not causation. They don't explain how, as we saw, why and how. And
Yeah.
to be able to do answer a how and why is ultimately how we are going to be able to impact the gross margins in a positive way of our customers. With that, I'll stop. Thank you very much for the
Yes.
opportunity to talk to you.
PG, we have questions flooding in as we
Okay.
speak. So I'll just read out to you the first question that we received. So this goes, have you seen or implemented any use cases in healthcare? I see a lot of potential there.
Yeah, this was not a final implementation, but in my experience, this especially happened during COVID, right? There was a situation where there was such a shortage of ICUs that people who come, very sick patients, but very few ICU beds available. So they have to do a triage, right? Who should go into the ICU for intubation and the real intensive procedures because of that shortage. And so the idea is collect. Fortunately, a hospital setting, so it's not like home. They're fully instrumented. There is pressure of oxygen. All the vital information is coming. So we try to create a system that will rank the patients as to where who should be the first to get the next free ICU bed. Then we compare it with the doctor's own recommendation. So doctors are notorious, they don't want the machine to tell them what to do. So as they see more and more congruence, and in some cases where they missed it, they start building confidence in our solution. So that is one classic kind of um, application in uh, in healthcare. The other, I think, the lower hanging fruit. These are when you impact doctors' direct. I guess their basic income. Try to replace them. You see a lot of pushback. So it is better to focus on hospital operations. Can we, as a patient comes in, you clock when the patient walks in, and how long it took to see this thing, where was the holdup, then you went to the pharmacy. So as you start, can you improve the processing by getting data from each of these points and then create a digital twin of the hospital processes? And then, of course, in hospital procurement and in the US at least, I'm sure it's happening in India, um, simplifying the insurance, the payback that both the hospital, the doctor, and then finally the patient has to pay. So these are where some of the main applications in healthcare is today.
Wonderful. I think that was quite insightful, having covered the daily business as usual of for doctors. I see a very interesting question coming in. So, how much time does it take to create a digital twin of a product?
It depends. When start from scratch, it does take some time. So you may have seen I kind of flashed through it, our process. So what I did was, I've developed, I don't know, since Rockwell Automation, about half a dozen digital twins. So there is a lot of accumulated experience. So what we did when I came to eMinds, enterprise minds, is to first, before we engage a lot of customers, create what we call these Lego blocks. So the digital twin Lego blocks are all finished. When you go to a customer and they say, this is my use case, this is the pain point, we assemble the Lego blocks. We may have to build one more, two more Lego blocks, and maybe you put some glue here and there. And then, of course, always UI, everybody's is different. So we are able to finish a digital twin from scratch, that is from engaging this customer in about 4 months for the first production deployment. But that is because we have the pre-prepared stuff. If you start from scratch, I think it's at least a minimum year's work if
Okay,
you have experienced people working for you.
sure. Yeah. So, another one which catches my eye immediately is today's company are becoming more and more focused towards sustainability. Could you throw some light on how digital twin is going along the lines, empowering enterprises to become more sustainable?
So when it comes to sustainability, all I can say is on a personal level, I try to not create waste and, we recycle everything. No, I'm joking. Sustainability is, again, not an area that I've focused a lot on. The thinking would be the same as something like, in my opinion, like smart cities. So what is smart city is a big application of digital twins, right? You create not just a 3D picture of the city, but how the municipal services, water supply, electricity, sewers, how they're all connected, tall buildings, office towers, apartment blocks, how they're consuming traffic. So each of them could be like a node in that fryer that we talked about, and then we connect them together to see their dynamics. So, for example, or one case maybe here is an indirect way to impact the environment. One case that I know about is for traffic control. So let's say going from one end of the city to the other. In Bangalore, I hear that takes 10 hours or 8 hours. I'm not sure. But let's say it takes 1 hour. And if you can cut it down, the average transit time to 30, you're really impacting the environment sustainability in a very positive way. So you can do that by, every traffic light has a camera now, and they can do local analytics and just send back information about how many cars are lined up, right? So the digital twin at the back will combine them and say, this is the sequence of red and green lights for the traffic lights. So the traffic flows, because it changes continuously. There are side streets, people coming. In the evening, it goes one way, morning, it goes the other way. So it dynamically controls it so that now the transit is in 30 minutes instead of 1 hour, and you have put much less, half as much carbon into the atmosphere. So that's a sustainability application.
Yeah. And network science is definitely considering one of the critical vectors for all of its deep tech endeavors that it does for enterprises. Sustainability is at the center. So, if we have time for one more question, uh, or perhaps we are just run out of time, PG, and we'll definitely write to you the the questions, and I request all of the viewers who have tuned in to just stay back for a poll. I will shortly display the poll on the screen. Kindly take the poll, which will help us to serve you
Uh,
better. Yeah,
I would like to have a word to thank all the audience who joined um, from
indeed.
wherever you are in the world. Namaste, konnichiwa, ni hao, and hello. So please reach out to me or to Prashant for any additional information. Uh, Thank you very much, Prashant, for the opportunity on Network Science.
Thanks, PG. Thank you, everyone. And I hope that everyone is much more knowledgeable about the deep tech and especially digital twin now. With that, I bid adieu to all of you and looking forward for the next edition of co-create.ai by Network Science. Thanks, everyone.
Bye
Bye.
bye.
Cheers.